I did want to call attention before we dive in to some of our resources that might be helpful. A few of you in the survey mentioned, jargon's kind of tricky, maybe terms, equivalents in data and things like that. So here's the website. If you go over to the resources tab, there's lots of great stuff for you here. We have cheat sheets, so if you want to review any of the terms or things that were covered, if you scroll down a little bit, you can find reference, big book of R jargon, if you need to look anything up, terminology, and then scroll down just a little bit, and you can find R versus Stata, and Carrie also posted kind of a reference guide in the Slack. So this can be a nice reference. I'm not super familiar with Stata, and so I'm not maybe the person to ask about what the exact equivalent function is. But definitely there are resources because people have been in your shoes before. Also, if there's anything you miss, of course, the lectures are recorded, but we also have our recordings from last time if maybe you want to hear it a different way. Might be slightly different content, but that's all there for you as well. All right, so we talked a little bit about R Studio yesterday, a little bit about the basics and history of R, but let's really get into some nitty-gritty about the language and what's actually happening in the console, in the R chunks that you're creating. Okay, I hate to start off with this, but some of the new user frustrations that you may run into, definitely possible that you encounter some challenges. We did this a little bit yesterday, but different versions of software can kind of cause us trouble sometimes. Our packages aren't necessarily created with compatibility in mind always. Most of the times things work, but sometimes there's a little bit of massaging that has to happen. Data type problems. We'll talk more about this throughout the class, but basically is R interpreting something as a character or a string type? It's like a word or letter. Or is it a number? Is it something you can perform math on? Working directory problems, trying to read files or discover files that R can't find. It doesn't know where to look for what you're trying to ask. We'll talk about this more later today. And then, of course, typos, the perennial bane of our existence, right? R is case sensitive, so lowercase x and uppercase X are different. So when you are going to name your objects, make sure you pay attention to that. Also, just spelling, right? So making sure that your functions are spelled correctly. Not always the most interpretable error message. We've provided a few in the help tab of the website, provided a few common error messages you might encounter, but always check to make sure, okay, double check, is everything spelled right? Can I move on? Yes, great. You may run into that. Okay, so as I'm going through these slides, a command or a code chunk will look like this in gray. So I have some code that says print I'm code, and then output will appear below it if there is relevant output. So here you see this kind of 1 for line 1 of the output and the expected output here, which is a printed statement. So it'll look like this. Hopefully that is pretty easy to follow. Of course, just ask questions if you forget or not quite sure why something looks the way it does. Okay, so first and foremost, R can be a calculator. It's a very elaborate calculator, perhaps, but it can do basic mathematical operations. So 2 + 2 is 4. We expect that output. 2 × 4 is 8. 2 to the 3 is 8. And when we type those in R, R inherently thinks we want to print the result. Okay, so what does that actually look like? If I do 2 + 2, everyone can see that okay, and I hit enter, and this is my console, I'm not in an R markdown or anything, hit enter, and it thinks I want to print it. Okay. Okay, so it's a full calculator, can do all kinds of cool stuff. So maybe play around with it a little bit. The plus, minus, divide, star are just our arithmetic that we learned when we were very small. You can use the caret or the 2 stars to create something raised to a certain power. Parentheses work just like we would expect them to in math, and sometimes it's useful to find the remainder of something that's divided. You can do that with the double percent sign there. Okay. Okay, so we can continue to play around with this. R can do complex stuff, figure out order of operations, and can even solve some viral math problems for you. I just think this is so funny that only in today's day and age can we have a viral math problem, but with the power of R, there's no debate. You can solve it and win the Facebook battle with your relatives. All right, so let's take some time to try evaluating some of the following. So this will be pretty straightforward. I'm going to just have my R window open here, scrunch it down just a little bit. Okay, so I do 2 plus 2 times 3 divided by 4. And this is kind of, I don't love the way that this is formatted. Kind of did this on purpose. This looks kind of like -3, right? So spacing is kind of important in R just to make sure things look nice. Here, the spacing doesn't affect the outcome, but yeah, we want to be aware that we're doing that and that it's readable for us at a future time. Okay, so hopefully that's what we expect. Try another one. Okay, so we can do math problems all day in R as a calculator. Okay, so maybe we have some bit of code that we don't want to run, but we want to leave a comment for ourselves or toggle some code on and off inside a code chunk. We can use the pound sign or the hashtag sign to create a comment. Okay, so if I have my code chunk here that's kind of output to the slide, this is a comment. Basically nothing after that symbol is evaluated. This, so if you use more than one, it's still a comment. You can use as many as you want. And these can be to the right of code. Okay, so if I go back to R and I say 2 plus 2 or 2 plus 4, and then I have a comment -6, right? It's not going to evaluate this part because it's after a comment. Okay, so this is good to leave notes for myself if you want. Of course, your R Markdown has space for you to create notes kind of outside of those R chunks, but if you want to just do a little reminder line by line or something like that, comments can be a great way to do that. And of course, you may encounter those in script that you find elsewhere. All right, so this is super important. So assigning values to objects. Okay, so if we're trying to think about keeping something in memory to use later. So you can create objects from within the R environment and from files in your computer. R uses this basically left-hand arrow to assign values to an object name. You might also see this equal sign used. That's not best practice. It does very similar operation, but not quite identical. And as a reminder, object names are case sensitive. Big X, little x are different. Okay, and so this works much like, you would think of algebra working. We're assigning the value of 2 to this x variable, and so I can use that later, right? So if I say x is 2, right? I don't get any output, but look, I've got this value now in my environment, okay? And I can just type it in and print that value out if I want. Okay, and just like with algebra, I can perform operations on it. So I've got this object called x, and I can do some math on it as long as it's a number. Same thing down here. Okay, so what we're going to be working with most in the rest of this class is a object class or data type called a data frame. And we'll talk definitely more about this later. But this is essentially a spreadsheet with rows. Those could be different subjects, patients or something like that, observations, and columns, which are usually different variables, attributes of that patient, for example. And data frames are a little bit more advanced, right? It's got, it's matrix-like. It's really big and kind of complicated. There's a lot of metadata, perhaps. They're more advanced objects, so we'll start with some simple ones just to get rolling. Okay, so one-dimensional classes are called vectors. And vectors can have multiple sets of observations, but basically each item in that vector has to be the same class. So we'll talk more about classes again, we'll talk more about that later. But basically for now, we'll think about some are strings or character types. They're a word, they have no numeric meaning, and then numeric ones that we can perform math on, okay? And so if we want to ask, okay, well, what's the class of x? We can go ahead and ask that. And remember, we assigned it up here. Okay, tells us it's numeric. And if we want to create a new variable or new object called y, and we'll give it some text. So we can type y or we can type print y, it gives us the same output here. We can ask the class and it'll tell us, oh, it's not numeric, it's character type. Okay, it's got letters and non-numeric meaning here. Okay, so let's do a little bit of practice. We'll try assigning our name to our object called name, okay? Okay, so if I want the new object to be called name, I'm gonna type that in. And actually, let's go ahead and open up a new R Markdown just so I can kind of keep track of this, okay? I'm gonna scroll down, create an R chunk, so this green button. And this way I can kind of save what I'm working on, right? So let's say I'm creating an object called name, and I want to assign that my full name, okay? And in R, we want our character type to be surrounded by quotes, okay? So let's go ahead and type my name out. I'll go ahead and run this chunk. Okay. Kind of fun thing about R is if you don't get any output, usually that means things went okay and there's no need to panic. So this seems good. I have a new object in my environment over here. So name is Ava Hoffman. Watch what happens if I forget my quotes here. Right? unexpected symbol, right? It's encountering these letters and the space, and it doesn't know what to do with that. Okay, so always make sure your text is in quotations. Okay, so yeah, that's what we should get if we type in name. We should get that output. All right, the combine function. We're going to be using this a lot. So, this is Ava Hoffman is great and all, right? It's a character object, but maybe we want to combine things, right? We want to have multiple objects kind of stored together. It collects, combines, or joins single or objects into a vector. Okay, so commonly used for creating vectors of numbers, character strings, and other data types. Okay, so let's say we want to combine a couple of numbers. So I'll make X be assigned to a combined list here, or combined vector. 1, and I'm going to separate the items I want to combine with commas. So up next, 4, 6, 8. Okay. All right, again, don't get any output, but if I type in X, I can see the output there, and I can ask for the class, and it'll tell me that all of the items in that vector are numeric. So they have to all be the same type. Okay, so we'll try to use combine on our name. So we'll try assigning our first and last name as 2 separate character objects or strings into a single vector called name2. Okay, so let's get rid of that. Again, the new object we're assigning is name2. And let's give this 2 items, but we'll need to use the combine function. So let's give it Ava, stick a comma in there, and tell it the next item, which is my last name. All right, let's run that chunk. Okay, again, no output. And if we do name2, should see 2 different items, and you see they're kind of separated, right? There's a space here as it's listing both of those items off. Okay, so we should see that. So let's talk really briefly about arguments, which are basically the contents that we give to an R function. So it's what we're providing. And in this case, R assumes that all the arguments that we're using should be objects contained in this new vector that we're making. And we'll talk more about this as we use more complicated functions, because sometimes we'll want to specify what that argument is for. Okay. And so here we've got 2 arguments. The first is this one, and the second argument is this one. Okay. All right, so sometimes it's helpful to know what the length of a vector is. And so we can do that with the length function. So if we've created, let's make sure X is still here. So I'm going to just print that. Okay, great. If we want to do length and figure out how long that vector is, we can just use the length function. Okay, so we have 4 different items, and remember they were separated by commas before. So in contrast to maybe some other languages like Python, if we have just one item in our vector, it's not going to count the individual characters, right? So it's not going to count how long the word is. It's just going to tell me that I have one. Okay, so little quiz time. What do we expect for the length of the name variable? What about the name to variable? What are the lengths for each? Okay, and so remember, name was just my name in quotes, one, a specific object there. And name to is a little bit different.
Probably 1 and 2 for the length.
Exactly, yes, thank you. All right, so if I do length name, I should, oops, hello. I should get 1. And length name 2, I should get 2. Okay, pretty straightforward. Hopefully this is all making sense. Not too complicated here. All right, so you can perform mathematical functions to entire vectors of numbers very easily in R. So if you wanted to add 2 to every item in X, you can do that. So it should output something of the same length that's added to all of the items here. So as a reminder, X is this, and then I do X plus 2, it changes those, okay? If you do multiplication, it does kind of works in the same way. It's not doing any weird matrix algebra or anything like that. And likewise, you can provide it with another vector, and it will add the first item of the vector to the first item of the first, second to the second, third to the third, etc. All right, so with that, we're going to break out into our first lab. We're going to get a little practice. So you can download the lab here. You can also access it from the website. If you go to here, the materials and schedule, you scroll all the way down to basic R. I think somebody maybe clicked on this yesterday, but the lab is right here. If you want to kind of move ahead, the keys are also here as well, just so you can kind of check your work if you want to. Okay, so not to give anything away, it sounds like some of you maybe had a chance to move on to part 2, but it's important to note that algebra can only be performed on numbers. Okay, so let me jump back over to R and scrunch this down just a little bit. If I go back over here, I have name 2, and I try to do, I want to divide this by 4. Yeah, I get this weird, like totally inscrutable error, but basically that means I can't do math on character types. Okay, R doesn't like that. Okay, so reassigning to a new object. So maybe there's times where we want to create something new. You can do as many of these new named objects as you like. And the nice thing about doing something like this is that I have this vector here, I have this variable or object X, and let's say I don't want to mess with X. This saves the new output as something else. So X is effectively protected, but I have a new object to work with. Okay, and so if I run this, so let's do it up here again in my code chunk, best practices here. So Y is X plus a vector. Y is now this vector, right? It's not hello world anymore, which is what we had kind of earlier in the lecture. So anytime you create an assignment like this, R takes the most recent one you did. Okay, so just try to be careful when you're assigning variables. Maybe you want to call it something new, just in case you don't want to lose your work from earlier in the code. Okay, so a little bit tricky, but thinking about reassigning, allowing us to make changes in place. So if we run something like this, the output and results print to the console, but those results aren't stored in an object. Here, we're storing the results in an object called Y, and we're protecting X. And then finally, let's say we don't care about, what X was before, we want to replace it. This allows us to kind of make an instantaneous change or change in place. X is being changed for all future applications. Okay, so we call this reassignment. Okay, so there's other things we might be interested in about our objects other than just class. The str function or structure function gives us the structure of an object. And so let's say, I want to know a little bit more about Y. I can do str Y, and it tells me a little bit here. Okay, so it's telling me, oh, it's a numeric type. It's got 1 through 4 elements, and it gives me a little bit of a preview of what's in there. And because this is a pretty small object, I can see actually all of the values. Okay. And so this can come in handy when we start dealing with a bigger or more complex objects. So let's say we have some object called Z. It's a really long numeric vector, but it's telling us it's numeric. It's got 100 elements, so 1 through 100 here. And it's giving me a preview of the first couple, but it says, all right, well, there's more kind of dangling off on the edge. You don't need to see them, but maybe you want to see just a couple to get a sense of what's in there. Maybe do a gut check. Order of magnitude seems okay to you, but this can be a good way to kind of preview what's going on. All right, so this is the end of basic R. We'll do a little bit more lab. It sounds like folks already maybe moved on a little bit, which is fine. But let's summarize here. So R functions as a calculator. That's, at its most basic level. So if you come away with nothing else, you can have a really fancy calculator on your computer. We use the left-hand arrow to save or assign values in memory to objects of a specific name. So a object called X has some underlying values associated with it, and I can use it and play around with it in R. The combine function allows us to combine multiple elements inside a vector, and we have a couple of functions that help us tell or learn more information about an object. Specifically, length is really great for vectors to see how long they are. Class tells us, is it a character type? Is it a numeric that I can perform math on? And structure tells us a little bit more, gives us a little bit more information. It tells us both the class, gives us some idea of the length, and gives us a little bit of a preview. Okay, so str is a really nice one to give you a lot of information right away and quickly.